Jai Hind. Today we are doing 11th class maths limits. In limits and derivatives, we are considering first question. The question is evaluate x plus 1 whole power 5 minus 1 upon x when x limit x tends to 0. So when I replace this value x equal to 0 in numerator, I get 0 because 0 plus 1 power 5 it is 1. 1 power 5. So 1 power 5 is 1. 1 minus 1 is 0. So numerator is 0. Similarly denominator is also 0. So to solve it, we need to check that is there 0 by 0 is term is there. This is called indeterminate term. So we avoid this indeterminate term. So how we solve? We assume here x plus 1 as another variable. So x plus 1 we consider as suppose y. So we change the limit. In this case we write the limit y tends to what? If x is 0 then 0 plus 1 1. So y limit is 1. So this x plus 1 becomes y. So y raised power 5 minus 1 upon this x. X value is y minus 1 because by transposing, so y minus 1. So it means we are assuming here this value. So x is y minus 1. This is minus, not. So y minus 1. Now using the identity of y raised power 5 minus 1. So using this identity, we factorize this numerator. If we don't know the factorization of y5 minus 1, then what we do? We divide by y minus 1. It means long division method we can imply here. So long division method, our divisor is y minus 1 and dividend is y5 minus 1. So we divide. So in this case, we write the 0y raised power 4, 0y raised power cube, 0y square and 0y, then constant term 1. Now divide. First term divide first term. y5 divide y, we get y raised power 4. So y raised power 4 multiply both the divisor. So it become y raised power 5. Then minus y raised power 4. Now changing the sign of subtrahend, then add. So this become 0 and this become y raised power 4. Again other terms we write as it is. This is long division method. So it needed space more. So rough work is more important here. Now y4 is the first term. Divide by y. We get y cube. Y cube. So we write in quotient y cube. Y cube multiply with both the divisor. Y cube multiply with y. It gives y4. Y cube multiply with minus 1. It gives minus y cube. So we write minus y cube. Changing the sign and adding. It gives first term 0 and second term y cube. Then plus 0 y square. Then plus 0 y. Then minus 1. Again first term divide first term, y cube divide y, we get y square. So y square multiply both the divisor. So y multiply with y square, it gives y cube. Then y square multiply with minus 1, it gives minus y square. Changing the sign and adding. So first term 0, second we get y square plus 0y minus 1. Again divide y square with y, we get answer y. So we write y square multiplying by divisor, then minus y, changing the sign and adding. So first term becomes 0, and in the last we get y minus 1. Again y minus 1 divide y minus 1 one time. So plus 1 we write down, and here we write y minus 1 and changing the sign and adding, it gives 0. So it means our answer is, for divide, answer is y power 4 plus y cube plus y square plus y plus 1. And in this answer, when we replace the y value is 1, because limit, there is limit y raised to limit y tends to 1. So I replace with 1, I get 1 power 4 plus 1 power 3 plus 1 power 2 plus 1 plus 1. So finally I got 1 power 4 is 1, 1 power 3 is 1, 1 square is 1. So 1 plus 1 plus 1 plus 1 plus 1, there is 5. So answer is 5. So limits answer of this question is 5. So this question can also be solved by simple method, because it is become hard by this method. It means rough work is more needed. So limit y tends to 1, y raised to power 5 minus 1 power 5 upon y minus 1. So here we can say it is derivative problem. Its value is n 5 y power 5 minus 1. It means 4. So it means when replaced with y equal to 1, so it gives us 5 into 1 power 4. It means 5 is the answer. This is the short method. So we can say limit x tends to a. So x power n minus a power n upon x minus a. Its value is n x power n minus 1. This is the answer. So according to this rule, this is called differentiation. So according to this, we can also get answer 5. This is the short method. So instead of x, we can write a raised power n minus 1. So there is 1 raised power 4. This is the formula, and a raised power n minus 1. Next problem is, evaluate limit x tends to 0, x plus 1 power 6 minus 1 upon x plus 1 whole square minus 1. In this question, again we see there is x, when we put 0, 0 plus 1 power 6. So 1 power 6 means 1, 1 minus 1 we get 0 in numerator. Similarly 1 plus 1, 0 plus 1 whole square, that means 1 square is 1, 1 minus 1 is 0, denominator 0. So 0 upon 0 is 0 by 0 in determinant terms. So what we do, we replace x plus 1 with another variable, that means y. So this is we replace here. So it gives us x equal to y minus 1, transposing to other side. So we replace x plus 1 with y, therefore, and limit now become x equal to 0. When I replace, y becomes 1. So I write limit y tends to 1, and in numerator I write y power 6 minus 1 upon y square minus 1. Now what we do, we know that the formula of differentiation is limit x tends to n x power n minus a raised power n upon x minus a. It is n a raised power n minus 1. This is our formula, and here not a n, here is a. This is the limit. So according to this formula, we can say that this is not matching with this our question. So to match it, what we do? We divide both numerator and denominator by y minus 1. By dividing both numerator and denominator y minus 1. So here is formula for x raised power n minus a raised power n upon x minus a equal to n a raised power n minus 1, and limit x tends to a. So here limit y raised to 1. So y raised power 6 minus 1 raised power 6 upon y minus 1. It gives us n is 6. So 6. A is 1. So 1 power n minus 1. So 6 minus 1, it means 5. Its power is 5. Similarly in denominator, there is 2. N is 2. So I write 2. 1 raised to power 2 minus 1, it means 1. So 1 power 5 is 1, and 1 power 1 is 1. So answer is 6 into 1 is 6, and 2 into 1 is 2. So 6 upon 2 is the answer. 6 upon 2 answer is 3. Next question is limit x tends to 0, 2x minus 3 power 6 square root x minus 1 upon 2x square plus x minus 3. So in this problem, we solve this problem by replacing x equal to 0. First we check is there is independent determinant term is available. So 0 by 0 term is available by plugging the value of x equal to 0. So we replace x equal to 0. So 2 into 0 minus 3 whole power 6 into square root x means square root 0 minus 1. And similarly we replace x with 0 in denominator. So 2 into 0 square plus 0 minus 3, and numerator become 2 into 0 is 0 minus 3 power 6 into minus 1. Square root 0 is 0, 0 minus 1 is minus 1, and in denominator 0 square is 0, 2 into 0 is 0, 0 plus 0 0 minus 3 in denominator left, minus numerator minus denominator, minus minus cancel. So minus 3 raised power 6 into 1 upon 3. So 1 multiply any number gives same number, and odd numbers powers even power, so it gives positive number. So minus 3 power 6, it will give the positive number, and 6 times 3 we can write, and 1 3 in denominator will cancel with numerators 1 3. So 3 raised power 5 will left. 3 raised power 5 value is 3 3 ja 9, 9 3 ja 27, 27 3 ja 81, 81 3 ja 81 3 ja 243. So answer of this question is 243. So sometimes we check is there indeterminate terms available or not. So here answer, by plugging the value of x equal to 0 we get. So we have to check first before solving the problem answer is available or 0 by 0 form available. So if 0 by 0 form available, then we use some method, otherwise we directly get the answer. Now in this question there is limit x tends to 0, x tan 4x upon 1 minus cos 4x. This is trigonometric based limit question. So limit x tends to 0, in numerator tan 4x can be written as divide by 4x multiply by 4x. So what happen? We use the identity of tan when x tends to 0, limit x tends to 0, tan x upon x, its value is 1. So this identity we are using here. So to use this identity, the angle of tan, that means x, should be divided by tan x with that angle, means x. So here is 4x in tan, so 4x we need to divide. So we multiply numerator 4x and denominator 4x. Therefore we write 4x multiply 4x divide. Now we can say limit is there, and this tan 4x upon 4x become 1. So what is left? X into 4x in numerator. So x into 4x means 4x square left in numerator upon 1 minus cos 2x. And in trigonometry, next identity we are using is cos 2x. Cos 2x has two formula. Cos 2x has two formula. 1 minus 2 sin square x, and another is 2 cos square x minus 1. So cos 2x we can replace by this first identity 1 minus 2 sin square x, because when I replace 1 minus 2 sin square x, this 1 and this 1 will cancel out. How? Look in solution. So when I replace this cos 2x with 1 minus 2 sin square x, so what happen? You can say the sign will change in the inside the bracket, and plus 1 minus 1 become 0 here now, and this sign also become positive. So 2 sin square x will left. Now 1 and 1 cancel, so 4x square upon 2 sin square x. And now trigonometric identity in limits we are using is limit x tends to 0 sin x upon x, its value is 1. This new limits in trigonometry we are using. So here we can say that 4x square upon 2 sin square x is left. So what we do? We divide. We can say, and here limit x tends to 0 is there. So x upon sin x, this square can taken common. Outside there is 4 upon 2, and outside there is limit x tends to 0. Isn't it? Our identity says this, and this also be true when reciprocal both side. It means numerator denominator change both side. So x upon sin x, it is also equal to 1. So this x upon sin x whole square, it's become 1 square. 4 upon 2 become 2 after plug in the limits. So 2 into 1 square is 2 1 ja 2. So answer is 2 for this limit trigonometric limit problem. So some mistake is there. There is cos 4x. Cos 4x. So we write cos 4x here, not 2x. So therefore it becomes 2 sin 2x. Half of this angle, so 2x will be there. So there is 2x also, and due to 2x there is 2x. So in whole square we can write. How we write 2x? This 4 we send inside, it become 2x square, and its value become 1 over 2, because 1 over 2 this 2 will left. So final answer is 1 over 2. This is changing the limit problem, and this type of problem is important for exam. So limit x tends to pi by 4 sin x minus cos x upon x minus pi by 4. So we replace y equal to x minus pi by 4. So what happened? This become y and limit become new limit will come. So x is pi by 4. So pi by 4 minus pi by 4 it means 0. Y tends to 0 and sin x value is y minus y plus pi by 4. Similarly minus cos x. So cos x means y plus pi by 4 over x minus pi by 4 is y. So after changing the limit, now we solve. Otherwise, when we directly check the answer, we can find out indeterminate term, 0 by 0 term is there. This is interesting question. So now what we do? We use sin a plus b identity and cos a plus b identity. So limit y tends to 0. We write down as it is. And sin a plus b identity is sin a cos b plus cos a sin b minus, there we also use identity cos a plus b identity is cos a cos b minus sin a sin b. If there is plus, then there will come minus. So this identity over y. Now what happened? The cos pi by 4 and sin pi by 4 has same value. Therefore this negative cos y, this positive cos y term will cancel out. So we cancel out this term. After opening the bracket, this become negative term, this become positive term. So cancel. Next will left term is limit y tends to 0. Sin y taken common from this and this term, first and last term. Inside the left is cos pi by 4 and this become positive also. Outside there is minus. So sin pi by 4 over y. So cos pi by 4 it means cos 45 and sin pi by 4 means sin 45. Both has value 1 by root 2 and sin y upon y, when limit y tends to 0, its value is 1. So we know limit x tends to 0, sin x upon x, its value is 1. According to this identity, this has one value, it gives us value 1. So 1 into the bracket cos pi by 4 is 1 by root 2, sin pi by 4 is 1 by root 2, taking LCM root 2 inside. So we get 1 plus 1, that means 2. 2 by root 2, it will give the answer square root 2. This is the answer of this problem. So next problem, limit x tends to 0 cos 2x minus 1 upon cos x minus 1. This is also NCERT problem. So in interesting problem, we use cos 2x identity. So in cos 2x identity, what we do? Otherwise, when we replace x equal to 0, we get 0 by 0 because cos 0 is 1. 1 minus 1 upon 1 minus 1. That means 0 by 0. So we use cos 2x identity. Its identity is 2 cos square x minus 1. This identity we use. The second identity for cos 2x is 1 minus 2 sin square x. And denominator we write as it is cos x minus 1. So 2 taken common because minus 1 become 2. So after taking 2 common, next term we get limit x tends to 0 and 2 taken common. So cos square x minus 1. So 1 can be written as 1 square. So it become identity of a square minus b square in numerator. So 1 is written as 1 square, a square minus b square. Its identity is a plus b. It means cos x plus 1 and cos x minus 1. This is a square minus b square identity is splitting, and denominator cos x minus 1 written as it is, and limit x tends to 0 written as it is. So numerators cos x minus 1 and denominators cos x minus 1 cancel out. Only left term is 2 cos x plus 1, and there is limit also in front. So we replace the x equal to 0 now. We get cos 0 plus 1. Cos 0 value is 1. So we get 2, 1 plus 1. So 2 times 2, it will give the answer 2 into 2, 4. 4 is the final answer. Next, our trigonometric problem is limit x tends to pi by 2 tan 2x upon x minus pi by 2. In this problem, we replace this x minus pi by 2 as another variable. So let x minus pi by 2 equal to y. So we replace. So x will be, that will give us y plus pi by 2. So it become tan 2x means 2y plus pi by 2 over, there is y and there is limit. Limit also change. So if I replace with x equal to pi by 2, so pi by 2 minus pi by 2, I get y equal to 0. Now this 2 in 10 multiply inside the bracket, distributive property. So it become 10 2y plus 2 times y pi by 2, that means pi. So it means pi plus 2y, 10 pi plus 2y. It is in which quadrant? So 10 pi plus 2 pi will get, so pi plus 2 pi, it means this is first quadrant, pi by 2. So pi means third quadrant, pi by 2, pi plus y, it means third quadrant. Third quadrant. So first, second, third, fourth. So all positive, all student sign positive. Then all students like tea and coffee. T means 10 positive in third quadrant. So it becomes 10 pi plus 2y. It gives us 10 2y. In pi, the name of trigonometric function does not change, and there is limit y tends to 0 written as it is. Now we see there is 2y in the 10, so we need 2, so we multiply 2 in both numerator and denominator. Now its formula become 1, because 10y upon y, when y tends to 0, its value is 1. So same angle is there, 2y, so its value is 1 into 2, it will give the answer final 2. Next, exponential problem. The question is e raised to power 4x minus 1 upon x, limit x tends to 0. Here the identity is, if x e raised to power x minus 1 upon x is there and limit x tends to 0, its value become 1. So according to this identity, there is 4x, so we need here 4. So how we make it 4? We make it 4 by multiplying 4 and dividing 4, and limit x tends to 0 as it is, we write. So it becomes 1, its value become 1. So 1 into 4, it gives us 4 answer. So next problem is limit x tends to 5 e power x minus e power 5 over x minus 5. So here we need x tends to 0. So there is not x tends to 0. So what we do? We replace x minus 5 equal to 0. That will give us x minus 5 equal to 0. So x minus y we replace with another variable y. So it means x minus x equal to y plus 5. So we replace x with y plus 5, and x minus 5 is, we assuming y. So x tends to 5, it means x tends to 5, it means 5 minus 5, y becomes 0. So we can change the limit y tends to 0, and in place of x we replace y plus 5 minus e raised to power 5 as it is written, over x we replace with y plus 5 minus 5 plus 5 cancel out, and left term will be limit y tends to 0, and here e raised to power y, e raised to power 5, according to exponential rule power added, so we separate out e raised to power 5, e raised to power 5 or minus e raised to power 5 upon y. This will left after simplifying. So what we do, we take e power 5 common. So after taking e power 5 common, e raised to power y minus 1 over y will left, and limit y tends to 0. So we replace y tends to 0. So e power 5, y minus 1 upon y, it gives us 1 value. So e raised to power 5 into 1. It means e raised to power 5 is the final answer. Next problem is on log. So log 1 plus 2x upon x when limit x tends to 0. So here we know the formula log x upon x when limit x tends to 0, its value is 1. So we know this, there is 2x, there is identity is like log 1 plus x, not log x. So according to there is 2x and there is also needed 2x. So how we make 2x? So we make 2x by multiplying and dividing numerator and denominator by 2. Now we can say this value become 1. So it's 1 into 2, that will give us 2 1 ja 2. Next our question is limit x tends to pi by 2 cos x upon pi by 2 minus x. In this question what we do, we need x tends to 0. So we write this pi by 2 minus x is another variable, let it equal to y. So transposing to other side x, so y pi by 2 minus y, it becomes x. Now replace, we can say if x equal to pi by 2, then y becomes 0. So we can change the limit y tends to 0, and cos x is written as pi by 2 minus y. Similarly pi by 2 minus x is written as pi by 2, x value is pi by 2 minus y, so y changing the sign. So cos pi by 2 minus y over y will left when limit is y tends to 0. So here cos 90 minus theta, it means first quadrant. So it means cos is positive but name is changed. So complementary angle property says it becomes sin y upon y. So limit y tends to 0 and sin y upon y, this is the identity, its value is 1. In the next question, limit x tends to 0, 1 minus cos 2x upon 2x square. So cos 2x is written as 1 minus 2 sin square x. This is the identity of cos 2x upon 2x square. Limit x tends to 0. So 1 cancel out, this become positive. So 2 sin square x over 2x square. Limit x tends to 0. So numerator 2 denominator 2 cancel out. So it become sin square x upon x square. Limit x tends to 0. It can be written as further limit x tends to 0, sin x upon x whole square. So this is the identity sin x upon x. When limit x tends to 0, its value is 1. So it becomes 1 square. 1 square answer is 1. Here is the problem. Limit x tends to 0, root x upon square root 16 plus root x minus 4. So this is the rationalized problem, and we denominator rationalize. Limit x tends to 0, square root x upon square root 16 plus square root x minus 4. This will multiply both numerator and denominator by square root 16 plus square root x plus 4 and square root 16 plus square root x minus plus 4. Both numerator and denominator multiply. So it become a square minus b square in denominator term. So it becomes 16 plus square root x minus 4 square. In numerator it becomes square root x bracket square root 16 plus square root x plus 4. Limit x tends to 0. So when we solve, so in denominator plus 16 and minus 16, because 4 square is 16 minus 16, so cancel out and left with square root x in denominator and numerator square root x cancel out. So finally we get square root 16 plus square root x plus 4 and limit x tends to 0, and we replace with x equal to 0. We get square root 16 plus 4. When we replace the limit x tends to 0, we get square root 16 plus 4. Square root 16 is 4. So 4 plus 4. Square root 16 is plus minus 4. So if plus 4 is there, then we get 8 answer. If minus 1 is there, then minus 4 plus 4 is 0. So this is the answer. In this problem, limit x tends to 0, log 1 plus 3x upon e की power 2x minus 1. So what we do, we in numerator and denominator both 1 plus 3x is there. So we divide and multiply by 3x. So 3x into 3x. And similarly in denominator, e power 2x minus 1 divide 2x and multiply 2x. So this x cancel out, 3 by 2 will left. So 3 by 2 we write outside, and there is also limit we write as it is, x tends to 0. So limit x tends to 0, 3 by 2, and its value is 1. So 3 by 2 log 1 plus 3x upon 3x, limit x tends to 0, and log 1 plus 3x upon 3x, its value is 1 upon, and similarly we write limit x tends to 0, e power 2x minus 1 upon e power 2x, its value is also 1. So 3 by 2 is our final answer. Next problem, limit x tends to 0, sin x plus 1x plus sin x upon x. So what we do, we need to separate out both the term. So I think this is complete angle. So we first shift this and break it, limit x tends to 0. So what we do, we multiply both, because angle is not same. So we multiply both x plus 1, numerator and denominator, x plus 1, and here is also already 1. Next is we can separate out limit x tends to 0, sin x plus 1 into x, and in denominator also x plus 1 into x into x plus 1 plus limit x tends to 0, sin x upon x. So we know that angle is same. So sin x upon x, when x tends to 0, its value is 1. So it is 1 into x plus 1, and here is limit x tends to 0 for this x plus this is also 1. So when we replace x equal to 0, it becomes 0 plus 1, 1 plus 1. So final answer is 2. So this is also interesting question. 1 minus cos x upon x sin x. Limit x tends to 0. In this question, we can say how cos 2x. It is cos 2x identity we can use. So cos 2x is identity is 1 minus 2 sin square x. Half angle is there. If 2x is there, if x is there, then there is x by 2. So in numerator we can write 1 minus 2 sin square x by 2, isn't it? So in denominator we write as it is, and since sin x is there, so we multiply and divide both by x, and limit x tends to 0 written as it is. Limit x tends to 0 written as it is. 1 cancel out in numerator, and this positive term become y. 2 minus gives positive. So 2 sin square x by 2 into, and x into x, it become x square, and we can say there is limit x tends to 0, and denominator also there is second term limit x tends to 0, and denominator there is also sin x upon x. So this become 1, and now this first term we solve, and there is divide by 4 and multiply by 4, so it become x by 2 whole square. X by 2 whole square means in numerator and denominator we can say 2 by 4 is written, then it is nothing but sin x by 2 upon x by 2 whole square, and limit x tends to 0. So its identity become 1. So 2 by 4 means 1 by 2 is the final answer. 2 by 4 means 1 by 2 after cancel out. In our next problem, there is limit x tends to 0, 1 minus sin cube x upon 3 cos square x. So here we use a cube minus b cube identity. So a cube minus b cube formula is a minus b a square plus ab plus b square. This is the identity. So we are using this. So 1 minus sin x in first bracket, in second bracket 1 plus sin x into 1, that gives us sin x plus sin square x. So according to this identity we split out in numerator and denominator 3 cos square x written as it is. Outside there is limit x tends to 0, and we see the cos square x, denominator cos square x, this is also written as 1 minus sin square x, and further it splits out into a square minus b square identity. So it will give us 1 minus numerator written as it is. In denominator we see 3 cos square is 1 minus sin square x, and its identity become 1 minus sin x into 1 plus sin x in denominator, and numerators another bracket written as it is 1 plus sin x plus sin square x. So 1 minus sin x cancel out from numerator denominator, limit x tends to 0 is written, and if I replace the value, so first I simplified 1 plus sin x plus sin square x, left term we write upon 3 1 plus sin x, and there is limit x tends to 0, and we replace x 0, so sin 0 is 0, so it become 1 plus 0 denominator it become 3 into 1 plus 0 So in denominator we get 3 and in numerator we get 1. So 1 by 3 is the final answer of this question. This is very interesting question. So limit x tends to 0, 10x minus sin x upon x cube. So 10x is sin x upon cos x, and limit x tends to 0 written as it is. So sin x upon cos x minus sin x upon x cube. Taking sin x common in numerator, and 1x we write here from x cube, inside 1 upon cos x minus 1 upon x square written, and there is limit x tends to 0. Since sin x upon x, when x tends to 0 it's become 1, so we remove it. Next is limit x tends to 0, and this term we solve taking cos x common, taking cos x LCM. So 1 minus cos x numerator upon cos x upon x square, this will left. So 1 minus cos x upon x square cos x, this type of problem we have solved earlier. So 1 minus cos x can further be using cos 2x formula, we write 1 minus 2 sin square x by 2, so it becomes plus 2 sin square x by 2 over x square cos x. Now 1 cancel out, 2 sin square x by 2 upon x square is there, so this is further simplified. Since cos x, when x tends to 0 its value is 1, so limit x tends to 0, 1 upon cos x, its value is 1, and limit x tends to 0, 2 sin square x by 2, and there is x square. So this can be written as 4 multiply in numerator, 4 multiply in denominator. So denominator multiply 4 is written as 2 square, so it becomes x by 2 whole square. So it gives us, this gives us 1 and this gives us 2 by 4, because when we say limit x tends to 0 and sin x by 2 upon x by 2 whole square is there, so its value is 1. So 1 by 2, 2 by 4 means 1 by 2 is the final answer of this question. So this question is carrying two questions combination, therefore it is some more important. So today's we have done near about most important questions of limits based chapter. I hope you have enjoyed. You can write your notes and able to solve all the problems again. Okay.